Good day, ladies and gents. I hope you guys are okay. Welcome back in NTLAMZA'S chamber. Today I'm doing physical sciences. So the topic I'm going to focus in is electric circuits. So this video is going to cover the content that is done in grade 9, 10, 11 and 12. So any learner from those grades can watch this video. Okay. So we know that there are two types of circuits. We have series and parallel circuit. Okay, before commencing, I know you guys are surprised to see me using this small board. The reason I'm doing that is because of this topic is kind of broad and has many calculations. So this board is going to be convenient for me. It's going to save a lot of time. Okay. So like I've said, we have two types of circuits. We have series circuits and parallel circuits. So I'm going to try and start with series circuits. I'm going to draw a simple circuit showing how the components are arranged in this circuit and how it looks like. Then I'm also going to show you guys how are we going to or are supposed to calculate current, resistance and also voltage in our circuit. Okay, let me use this small sketch. Let's say we have this series circuit with one cell having a resistor here, then also resistor here. So let's call our resistor the 2 ohm resistor, and then this one let's call it a 1 ohm resistor. Then let's assume that our battery has a voltage of 5 volts, and then let's say the current in our circuit, let's add an ammeter here. The ammeter is the component that measures the current in the circuit. Let's say our current is 2 amperes. Okay, so as you guys can see that the current is going to flow from the positive terminal of the battery as 2 amperes. So when the current flows, it is going to reach our 1 ohm resistor. Without being divided, it is going to be 2 amperes. After that, the same 2 amperes is going to pass and reach the 2 ohm resistor. And after that, it's going to continue as 2 amperes until it returns back to the battery. So you guys are able to see that there's no the current that is going to be divided in these resistors. That's why we say they are in series with the battery. So we've noticed that in a series the current is the same in all resistors. So it means that total current is the same as the current of resistor 1 is also the same as the current of resistor 2. Okay, so now let's try and check our voltage. So the total voltage here, which is this voltage. So voltage is the potential difference or the amount of energy that the battery can supply in this circuit. So as all of us can see that total voltage is going to be voltage of resistor 1 plus voltage of resistor 2. So it means that the voltage is not the same in these resistors because of they have different values. Meaning if we put something that is going to measure the resistance here or the voltage here, when we put the voltmeter here, the voltmeter is going to read different readings compared to the 2 ohm resistor, because of when we talk about resistor, we're talking about something that is going to resist the flow of current. So it means that the energy used here is not the same as the energy used in this resistor. That's why we say the total voltage, this voltage is going to be this voltage is going to pass here plus the voltage is going to pass here. Then they must give us total of 5 volts. Okay, then let's see about resistance. So the total resistance is going to be resistor 1 plus resistor 2. So it means that the total resistance of this circuit is going to be 2 ohms plus 1 ohm, which is 3 ohms. Okay, I hope you guys are able to see that. I think it doesn't appear. Okay, this is what I've done here. It's going to be total resistance equals to R1 plus R2. Okay, I hope you guys are able to see that. Okay. Okay, a little bit of problem here. Okay, I think it's okay. Okay, so let's try and check with the parallel circuit. So you want to know how things work in a parallel circuit. So I'm going to try and draw a small sketch showing a parallel circuit and how it looks like. So I'm going to use a sketch having this resistor and also having this resistor. And then let's say we have an ammeter here that is going to measure our current. We have the ammeter. Okay, and then let's say this ammeter is going to measure 4 amperes of current, and then the voltage, let's say, is 4 volts. Okay, and then let's say this is 3 ohm resistor, this one is 2 ohm resistor. Okay, so as all of you guys can see that our resistors are parallel to each other. They are parallel to each other. We have parallel lines, but then these are the wires. So these wires are parallel with each other, making these resistors to be parallel. So that's why we call it a parallel circuit. Okay, so in a parallel circuit we have something strange or something interesting happening. So when the current flows from the battery, this 4 amperes, when it reaches this point, it's going to split. Small portion is going to go to this resistor, then another portion is going to come to this resistor. So it means that there's a splitting of current in a parallel circuit, so that each and every resistor can get something, so that it can be able to function. So, but then we cannot guess how many amperes are going to pass here and here, because of our resistors are not equal in quantity. So it means that this resistor have higher resistance, 3 ohms, so it's going to resist more of the current. So it means that only small amount of current is going to pass here, because of when we talk about resistance, we're talking about the ability to prevent something from passing. Okay, and then some of the current is going to pass in this resistor. Okay, then we see our current coming, and then it's going to meet here. So when it meets here, then the current returns back to 4 amperes, and then going to flow back to the battery. Okay, so it means that the current is shared, is not equal in these resistors, like in our series where we saw the current total equals to current of resistor 1 and then current of resistor 2. Okay, so it means that total current here is going to be the current of resistor 1 plus the current of resistor 2. Okay, So it means that this is what we're going to get. Okay, so let me try to create a space. Okay, I think I'm going to continue here. And then what about the voltage? So the voltage here, it is equal in all of our resistors because of they are in parallel combination with each other. So it means that the total voltage is going to be the same as of voltage 1 is going to be the same as of resistor 2. Okay, so it means that this 4 volt is going to pass here, is also going to pass here, so it is the same. Okay, so you have to know that at all the times. So you can see here it's different. The total voltage is going to be the combination of the voltage of these two resistors. Okay, so what about a resistance? So you want to see how we deal with resistance, so I'm going to do it here. So the resistance here, because of they are in parallel combination with each other, so we're going to use the reciprocal. So the reciprocal is also known as the opposite, since they share the current. So we're going to say 1 over the resistors that are in parallel is going to be the same as 1 over resistor 1 plus 1 over resistor 2. Okay, so this is what I'm trying to say. So 1 over Rp resistor in parallel is equals to 1 over resistor 1 plus 1 over resistor 2. Okay, so these are the basics that you have to know when you deal with circuits. So you have to know these basics. They are taught from grade 9. So once you know these basics, you'll be able to do the calculations that involve circuits. Okay, so this is a short video where I try to show you basics. Okay, so in the next video I'm going to get into details about meters. I'm going to do the calculations involving these two types of circuits. I hope you guys were able to understand that. Thank you.